Hi everyone, I have a question here that has a low difficulty rating on Kattis. I think it's 1.5, yes, 1.5. And it is indeed easy because you can solve it by just running some loops. But I think this is a good opportunity to talk about a bit of math. In particular, I want to talk about how to sum up a series, so let's get into it. In this question, you are given an integer n, and you have to work out the sum of three things. First, you have to work out the sum of the first n positive integers, and then you have to work out the sum of the first n odd integers, and then the sum of the first n even integers. So probably easier to illustrate it to you. Let's say that n equal to 5, then you have to work out the consecutive the sum of consecutive numbers from 1 to 5, so that's going to be 15, and then you have to work out just the odd numbers and then just the even numbers. Okay, so that's what you have to do, and as always, try to give it a go yourself first. As I said, you can do it with just simple loops, and this is a good time to pause the video and give it a go if you want. I'm not going to do this question using a for loop because with these kind of questions, they can make n big enough so that you can't just simulate it. It'll take too much time. Or maybe n is so big so that you can't store the value in an int and the operation becomes slower. What I'm going to do is I'm going to use the formula for the sum of arithmetic progression. And this is something that is useful for you to know. So the formula is given here. This is something I learned back in high school. I used to remember how to derive it, but I guess not anymore. I just know how to use it now. So if you have a sum, let's look at the sum of odd numbers. So you have 1 plus 3 plus 5 plus 7 plus 9. So there are 5 terms. A is the starting term. So let's go down a bit. A here is the starting term. So A is equal to 1, n is another term, so that's equal to 5, and then d is the difference. So this whole formula will become 5 divided by 2 multiplied by 2 times 1 plus n minus 1, which is going to be 4 times d. Now, you have to be careful when using this on a computer. Sorry, d is equal to 2. When you put this formula inside a computer, be careful that this is not an integer division, as in 5 divided by 2 is 2.5. If you just plug that inside the Java, you're going to get 2. So be careful with that. You're guaranteed to always get a whole number because you see how this is n divided by 2, and you have n minus 1 here, and that's a 2 as well. So if this is an odd number, you guarantee that this whole term will be even. So 2 will always divide one of either n or this one cleanly. So you'll always get a whole number. Anyway, if we do this, what do we get anyway? 2 plus 8 is 10. 10 times 5 divided by 2 is 25. Is that correct? 4, 9, 9 plus 7 is 16, 16 plus 9 is 25. Yes, that is correct. So you can use this formula, just plug it in. Maybe we'll try that. Yeah, let's give it a try. Okay, so I need the formula here. Let's make this a bit to the left. Okay, that's the formula. Okay. All right, so I need 3 terms. Sorry, I need 3 sums. Let's call it sum 1, sum 2, sum 3. Oh, by the way, you have to output the case number. Well, if the first input is 3, you're going to have 3 cases, 1, 2, 3. I'm not going to take for granted that they're going to give me 1, 2, 3 in order. So what I'm going to do is I'm going to input that. What do I want to call it? C equal to int.nextInt. And I'm going to output that C. Whatever I read here, I'm going to output it because they may, I don't know, is there a guarantee that the data set number is in order? No, because they may give you like 100, case 100, case 101, case 102. So safer to just do C. Okay. Now bring back the formula again. So I need to work out the first n numbers. So let's say sum 1 is equal to, alright, so I need to read in n equal to in.nextInt. So that's going to be n. I'm going to have n. So here's where you have to be careful with the divided by 2. Probably what I will do is I'll divide by 2 at the very end. So I'm going to do n. I'll divide by 2 times. The first one's always going to be 1. Well, in the case of all numbers, you summing 1 plus 2 plus 3. The first sum's going to be 1 plus n minus 1 times the difference is just 1. So this is the whole thing, and I'll divide it by 2. Okay, that's the first sum. The second sum. And the third sum. Second sum is the same, except that the difference is 2. You start from 1 as well. So that will stay the same. For the even numbers, you start at 2, and the difference will also be 2. I hope I'm doing this right. Well, let's give it a go. Alright, so I'm going to output C, the case number, plus, and then I will output sum 1, sum 2, and sum 3. So let's run that. Copy, paste. I got, oh, I need a new line. I need to press enter as well, but let's just restart it. Oops. Okay, run it. Is that correct? 501. Yep. So that works. Should we try to submit it? Yeah, I'll try to submit it now and make sure it works. So just bear with me for a second. Java. Just do editor. Okay. Oh, only 2 test cases. Okay, so that's not the end of it. I want to talk about something else. And that is about the sum of the first n integers. Now, sure, if you're going into a competition, then you just have that formula handy with you. Just write it down, take it with you. And just in real life, whenever you have to do something like this, sure, just use that. But if somehow you don't have access, to the formula, and you don't memorize it, you don't remember it, that's actually an easy way to work to do this question. So let's start with the sum of the first n integers. So I'm going to write 1 plus 2. Let's make it concrete for now. Let's just do 1 up to 5. There is a very easy formula that you can memorize for the summation. It is n times n plus 1 divided by 2. And as before, you're guaranteed to have a whole number here, because if n is odd, then n plus 1 is going to be even, or vice versa. And here, n is just the biggest number you have, like the last number. So if you have 1 up to 10, then this would be 10 times 10 plus 1 divided by 2. So in this case, n is equal to 5. The sum is going to be 5 times 6 divided by 2, which is 15. And if you add them up, you're going to get 15. So that is correct. This is for formula. I learned that in high school as well, I guess. You probably did too, just been a while. So that's the formula that we remember. But where this formula comes from is actually very simple. It's the legend has it that Gauss, the great mathematician, worked this out when he was 6-year-old or something. If I just write the whole sum in reverse, can you see what happens here? If I add these two, I'm going to get 6. If I add these two, I'm going to get 6. If I add these two, I'm going to get 6. And 6, and then 6, and so on. So what happened is, how many 6s do I have? I have 5 of them. Well, that's cool, because 5 was the number of terms. So I got 5, that's your n. 6 is just n plus 1, right? And why divided by 2? Well, because we have to sum. and we added twice. That's why you have to divide it by 2. I mean, if I generalize this to n plus 1, sorry, just up to n, and this would become, well, if you write in reverse, you're going to have n here, and then you're going to have, well, n minus 1, n minus 2, and so on. Sorry, this is not going to fit up to plus dot 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 up to 1. So again, what I'm trying to show here is that the first column here, they're going to add up to n plus 1. The second column, 2 plus n minus 1, is going to add up to n plus 1. So on, until the final one here is also going to add up to n plus 1. Okay, so that's where the formula comes from. You're adding n times n plus 1. You're adding n plus 1 n times, so that's n times n plus 1. Then you have divided by 2. You have to divide by 2 because you are adding the sum twice. So if you have to work out the sum of the first n integers, you can do that easily. Now, the question asks you to also work out the sum of the first n odd integers. So let me do it here. You have to work this out. If you know 1 plus 2 plus 3 plus 4 plus 5, and you know what the sum is, then you can work this out as well, can't you? Because what happens is you already have 1, 3, and 5 in the first sum. You are missing 7 and 9, and you have this 2 and 4, but the difference between 2 and 7 and the difference between 4 and 9 is the same. They're both 5. And you know how many terms you're missing. So you know the difference is going to be 10, but how do you write this in the formula? How do you work that out? Well, we're not going to write a nice formula for this because this is a bit of a hack. As in, I'm almost there. I know that the sum of the first n positive integers is equal to this. Then let me work out what's missing. I can see that I need 2 terms, and I have 2 terms here where the difference with the missing 2 terms is exactly 5, like I said before. So n is equal to 5. So if I do 5 times n divided by 2, right? Because that will give me the missing numbers. So the difference should be, this is 15, that's 25. The difference should be 10, right? So n is 5. 5 divided by 2 is going to be 2 because we're doing integer division now. And multiplied by n, which is 5, you get this should give you 25. Will this always work though, the formula? Well, one way to check is to add one more term, and let's see if it still holds. So now n is equal to 6, and is the difference 6 between the terms which are missing and the terms that we have? We have 2, 4, and 6. 2 goes to 7, 4 goes to 9, 6 goes to 11. The difference is still 5, so, well, that would be wrong. And on the other hand, this is still correct, because you need 3 terms. That is still 6 divided by 2. So how do we fix this? I'm going to try putting n minus 1 divided by 2 there. Why? Because I was thinking when n was equal to 5, 5 minus 1 divided by 2 is 2. So that was correct. So let's see if this works here now. Well, this is okay now because now that is the difference. And this is the number of terms. Like n divided by 2 is the number of terms, and n minus 1 is the difference. When we go back to 5 terms, 5 is the difference. And n minus 1 divided by 2, that would be 5 minus 1, 4 divided by 2. 2 is the number of missing terms. So it's just that when I do this, I get them flip, as in this becomes the difference, and n divided by 2, let me write it here, becomes the missing number of terms. So again, this is a hack. This is like, you know you're almost there. You know you remember the first formula, but you just need to work out the difference. So you know the partial sum, well, you know, 1, 3, 5. You got 1, 3, 5. You have to work out 7, 9, 11, and you want to work them out from what you have. So if you keep on extending the number of terms, you can check it again. This should be flipped again. What's the difference now? I need to make 9, 11, 13 from 2, 4, and 6. The difference is now 7. Okay, 7 is the difference. And how many? What's the number of terms? It's going to be 7 minus 1, 6 divided by 2, 3 terms. That's exactly correct. And this actually is correct. So I'm going to write it down here. So to work out sum 2, we need sum 1 plus n times n minus 1 divided by 2. And it doesn't matter how you do it actually, because you guarantee that one of them is going to be an even number. So n times n minus 1 will always be an even number. So then you can divide it cleanly with 2. So keep it there. Now, can you do the same with even numbers? As in sum of even numbers. So 2 plus 4 plus 8 plus 6. Let's just do 5 terms. So we're gonna have to change this for sure. But let's apply the same principle. So we have 2 and 4 and only 2 and 4. So we are missing 3 terms. We're missing 6, 8, and 10. And the difference between the terms that are missing and the terms that we have is 5. 1 goes to 6, 3 goes to 8, 5 goes to 10. Alright, so what do we have to change? How many terms are we missing again? We're missing 3 terms. So let's just do plus 1 there. Let's see if this works. I'm gonna extend it. Okay. How many terms are we missing? We're missing 3 terms. So that's actually n divided by 2. And what's the difference? We go from 1 to 8. 3 goes to 10. 5 goes to 12. It's actually n plus 1 now. The difference is 7. Oh. So it's just like before, you kind of flip it. This now gives you the number of missing terms. And this now, sorry, n divided by 2, what I mean, that gives you the number of missing terms, and now this gives you the difference. If I increase the number of terms by 1, the difference is still gonna be 7, because 1 still goes to 8, 3 goes to 10, 5 goes to 12, 7 goes to 14, and the difference is gonna be 7 still, but the number of missing terms is now 4. 1, 2, 3, 4, which is n plus 1 divided by 2. Okay, right? You got 8 divided by 2, that's equal to 4. Now, if you're good with math and algebra, you're probably pulling your hair out and saying, why am I doing all this? What's all this crap? Again, this is a hack. So the assumption here is that you remember how to do this formula, but you can't work out the rest of the sum. What I'm trying to say here is that there's always a way to figure it out, because the best solution is for you to know the sum of arithmetic progression formula. Right? That's always the best thing. But this is showing that even if you don't know it, you can still try to work it out. This is trying to use logic to work it out. And sometimes that's better than just memorizing a formula and using the formula, because if the formula no longer works, you're stuck, right? What you do then? But if you have enough logic to try to work it out like this, I mean, there's some like ingenuity here. Then when you're faced with a strange kind of sum, there's still a chance that you can work it out. You have to be able to think logically to get there. So this is an example of doing that. You don't need it. I mean, this is a very easy problem anyway, but it shows my struggle in trying to get the answer when I don't know the formula, and I can do it just by recognizing some patterns. So this one here is just gonna be sum 1 plus n times n plus 1 divided by 2. We can try to submit that. Let's go to Kattis, go back. Okay. That also got accepted. Now, there's actually a much easier way to do this question. Easier than memorizing the sum of arithmetic progression formula. Definitely easier than my second way, because I was a bit lost there. And is this. This is actually my first approach. There is something special about the sum of the first n odd integers. Don't know if you can see it. 1, 4, 9, 16. Do you want to guess what the next what's the next sum is? If I do 1 plus 3 plus 5 plus 7 plus 9? Well, what is 16 plus 9? 25. What's 25 plus 11? 36, and so on. So it is a well-known fact that the sum of the first n odd integers is always a square number, quadratic. As in the first 5 odd numbers gonna sum up to 5 squared. The first 10 odd numbers gonna sum up to 10 squared. That's it. But it's something that you need to know. Well, I'm telling you now, so now you do. So this is just n times n. Now, if you know the sum of the first n odd integers, how do you work out the sum of the first n even integers? So 2 plus 4 plus 6 plus 8 plus 10. I know this is 25. I know the first sum is 25. Then how do I work out this one? Well, how do you go from here, from the series of odd numbers, to here, the series of even numbers? Well, you go up by 1 on every term, right? How many terms do you have? 5. So this is just going to be 25 plus 5, 30. Add them up. 2, 6, 12, 20, 30. That's it. In fact, if you look at the, where's the problem description? Look at the input and output here. So 100 for sum 2 and 110 for sum 3. How many? What's n? 10. And what about sum 2 and sum 3 on the last output? 10020001 to 10030002. What's the difference? 1001. So in fact here, if you want to work out sum 3, it's just sum 2 plus n. So that's probably the best way to do this question, but that requires you to understand, well, this kind of special series. I'm sure it works. Let's try to submit that again. Java. And paste. And that's it for this video. Really, I just want to talk to you about this simple problem using a for loop, which you can do using for loop, I mean, but it's useful if you know how to do these formulas, like the sum of arithmetic progression, like 1 plus whatever. I think it was n over 2 times 2a plus n minus 1 times d. It's something that I've memorized, and before a competition you can write this down and bring it with you. But my second approach, which was sloppy, I guess, it talks about how you can try to derive the sum if you don't have all the information, but you have partial information. And finally, well, the last one was the greatest hack, because I just know the sum of the positive, like, odd numbers. So that makes me, they'll allow me to do something very, very simple. But anyway, that's all for today. I hope you learned something new, and that's it for me. Thank you.